afternoon, all of you. Today, we are holding the international webinar on advances in technology through innovation to entrepreneurship and advances in tissue engineering. So today's, we have the eminent speaker from international, like Dr. Avnish Parikh. He's the assistant professor, Department of Biotechnology, University of Technology and Applied Sciences, Ministry of Higher Education, Sultanate of Oman. And next, our distinguished speaker is Dr. Koel Garg, Associate Professor, Biomedical Engineering, School of Sciences and Engineering, St. Louis University, USA. So, I welcome my guest of today's eminent speaker, and I welcome the guest of honor also, Dr. Ajay Podarji, our Pro Vice Chancellor, Professor Dr. N.P. Kaushik ji, our Honorable Vice Chancellor for this particular webinar. I myself, Dean and Professor from the OM Sterling Global University. This particular webinar on the Engineers Day, why we are celebrating the Engineers Day. The main motto of celebrating the Engineers Day is that on 15th of September, India celebrates this particular day to recognize and honor the achievements of great engineer, Moksha Gundam Vishwesvaraya. The day is observed to commemorate the great work of engineers and also to encourage them to improve and to innovate also. So the main motto of, through celebrating the Engineers Day through innovation, the journey through innovation to the entrepreneurship. Technology entrepreneurship, also referred to as technology-based entrepreneurship and can be defined as the setting up of new enterprise by individuals or corporations to exploit technology innovation. And entrepreneurs also are essential for progress as they birth new, as innovators. The word innovation is typically, brings to mind technological solutions that have the power to change the world, I can say. So now I first of all, invite our Honorable Vice Chancellor and Pro Vice Chancellor for their keynote address as a guest of honors. I welcome them, and over to Professor Dr. N.P. Kaushik ji, Vice Chancellor. Over to you, sir.
Thank you, Dr. Shobna. Good afternoon, everybody present in this international webinar. It is a matter of great pleasure that we are organizing this international webinar on the occasion of Engineers Day, and we are celebrating this special day also. So first of all, I welcome distinguished speakers on this particular day. Dr.
Thank you, sir.
Avnish Parikh ji from Oman, and other distinguished speaker, Koel Garg ji from Louis Saint University, USA. I also welcome our Pro Vice Chancellor, Dr. Ajay Podarji, Dr. Shobna Podarji, Dean Corporate Relation, and other deans present in this webinar, our faculty members, and the students who are present in this webinar. So actually, we know that this Engineers Day is celebrated to commemorate the birth anniversary of great Bharat Ratna Moksha Gundam Vishwesvaraya ji, who actually born in Karnataka on 15 September 1861. So if we see, then he was even older than our great Gandhiji. And in 1968, with the efforts of many engineers and particularly the Institution of Engineers India, this 15 September was declared by the government as Engineers Day, and since then this day, that is 15th September, is celebrated as Engineers Day all over the country by the engineering institutions, the industries, and also the engineering departments. This day is also celebrated to appreciate the contribution of engineers by way of developing the infrastructure, promoting the manufacturing in various fields, and also providing the solutions of various problems of the society. As far as the life of our Mox Kundam Visvesvaraya is concerned, actually he lived for 102 years, and whole of his life was dedicated to the engineering inventions. So he is basically considered as the first engineer of the India, and he is also considered the father of the engineering. So this honor we have in our mind or heart. Visvesvaraya ji is considered to develop the great Krishnarjun Sagar Dam in Mysore. He developed many hydrological projects, and he remained for a few times in Pune, and there also he developed this Khadakwasla reservoir. He invented the automatic gates for the floods, and these floodgates are very important, and they saved the life of thousands of people during the flood in the Pune. He also established the Engineering College Bangalore, and he also established the Bank of Mysore, and there are so many credentials are there in his name. Actually, the topic of this seminar is different, but I am just emphasizing on the life of our Mox Kundam Visvesvaraya ji, and I would like to quote two very important incidents from the life of the Visvesvaraya ji, which actually shows his engineering skill. So, first is there was one time when he was traveling in a train, and it was the time of night, and it was before independence, so he was traveling with some English peoples also. And we know that at that time there was very difference of behavior with the Indians, and so as was with the Visvesvaraya ji also. So when he was actually sleeping on the bench, and his head was towards the window of the coach, and suddenly about in the midnight he felt some strange voice and vibrations, and he immediately woke up from his seat and pulled the chain, and he stopped the train. So when the train stopped, the railway people rushed to his coach, and they were very annoyed that why some person can stop the train in this midnight. And they asked Visvesvaraya ji also that why he has stopped the train at this moment. So he told that I felt some strange thing and strange vibrations, and I feel that at about 220 gauge. Actually, at that time, the this measuring unit was gauge, and we can approximately say at 220 meters or 200, less than few meters less than that, there is a breakage or crack in the rail. The railway people were not believing him, but when he emphasized that please check, otherwise there will be accident of the train. So it was really checked at that distance, and around that distance only the breakage of the rail putty was found, and they were very much astonished that how this person has recognized this fact, and if he could not see or we could not stop the train, there could be a very large, big accident, and many people could have died. So this is one of the very important incident which actually explains about his engineering skills. And second incident which I want to quote, that a group of engineers were sent to USA for studying some industries and machineries, in which some English engineers were also involved, and some of the Indian engineers were there. One of them was Vox Gundam Visvesriyaji. So actually, at one of the site, the machinery was installed at a height of about 75 feet, and the engineer in charge at the site told the group that whosoever want to see the working of machinery, they have to go up by ladder, and they can see, they can go there and they can see. So as we know that most of the English people denied to go up, but in spite of having the old age, Visvesvarayaji immediately said yes, and he went up to the top, uh, uh, climbing 75 feet, and he actually sees. So this actually shows his keen interest in understanding the engineering problems. So many things are related to our great Visvesvarayaji, and I feel that the students who are pursuing their engineering courses, they must actually read or study the life of Visvesvarayaji, so that they can be motivated to solve the problem. And at the last, we dedicate this day to our engineers. The engineers who build the world are the civil engineers, and the engineers who create magic in the world are the computer science engineers. The engineers who connect the world are the electronics and communication engineers. The engineers who give power and light to the world are the electrical engineers. The engineers who provide movement to the world are the mechanical engineers. The engineers who provide wings to the world are the aeronautical engineers. There can be so many examples of this. We are proud of our engineers, and we dedicate this day to the engineers. Happy Engineers Day to all. Thank you. Thank you, Dr. Sobna.
Thank you very much, sir. Indeed, you have mentioned very, very rightly that engineers are the architect of the modern time, and I believe that the world are on the verge to go on the new heights, and definitely engineers will be having the toughest work and toughest association and toughest support to take the world to the new heights. With this, I, Dr. Ajay Poddar, now I request Dr. Somna to please welcome our guest, Dr. Avinashji and Dr. Koyalji, formally, so that this international webinar can start it. We have around 50 people joined there. However, 2 of the classroom are also full. There are 250 students are there. So today the speakers will be having a very good communication between the students and the teachers, and I believe that this webinar will definitely enlighten with the new pedagogy and new things happening in the world through our eminent speakers. Over to you, Dr. Shobana.
Thank you, Dr. Ajay. It's really, it's a great pleasure for our home Sterling Global University that we are holding on this 21st century, related webinar, whether the journey started from innovation to entrepreneurship. Actually, it helps also the business sector to realize ourselves that the things that can make, how the things can be made available for the customers and what are the advances in the technology, because we are talking about today's, our eminent speaker are talking about the technology advances. And normally technologies, we can say, for example, the telephone, the light bulb, the television, the personal computer, these are the basic things that covers under it. And our eminent speaker, Mr. Avnish Parikh from University of Technology and Applied Sciences, Ministry of Higher Education, Sur Campus, Sultanate of Oman, having a great personality and a rich experience. And accordingly, he can share his input about the journey started from innovation to entrepreneurship. Over to you, sir, Dr. Amnish.
Thank you, ma'am. Distinguished Vice Chancellor, sir, Pro Vice Chancellor, sir, Shobna, ma'am, and other distinguished guests and speaker. Hope I am audible.
Yes, you are very much audible, sir.
Okay, thank you, ma'am. So, I thank you all for inviting me on this webinar session. Here, I would like to start with instead of like going with a simple webinar, I would like to make it a small hands-on brainstorming session in the form of a workshop. As I have shared the content before, so in this session, we are going to first understand what is innovation. We talk a lot about innovation, a lot. It's a new buzzword in the market. People used to talk about like environment, eco-friendly, reusable. These all were the words of like yesterday's. Now the new word is innovation. Everybody is talking about innovation. Everybody is talking about like entrepreneurship. Everybody is talking about unicorns. So what all is this, and how we can reach to that goal? Particularly, this address is to the students, and at the end, I would like to talk a little bit to the organizations and particularly the universities also in this webinar or workshop, you can say, in which we would like to see in-depth things. I'll not go much into details of the technologies that are available to hand, because the technologies are more of tools nowadays. Okay, so we would like to get into that. But before we start, we would like to see, is innovation really a new thing, or the human being with the beginning of the civilization is into innovation? So with your permission, sir, with your permission, Vice Chancellor, sir, I would like to start my presentation with a small video here.
Yeah, sir, please
Welcome,
carry
sir.
on.
Welcome.
Yeah, I'll share my screen. Is my screen visible?
Yes, the slides are not visible.
Yeah. I'm starting the video now.
Okay.
What is innovation? We are trying to understand the today's content with the help of this video. We are starting with one video.
The invisible world is not an empty void, but a reality waiting to be illuminated by the light of science. Innovation is inscribed into our nature, accompanying humans throughout civilization. From eyewear to integrated circuits, from compasses to GPS, innovation never stops. The spirit behind the age of discovery has led humans to explore the world we live in, from the tiniest of particles to the entire universe. Cristoforo Colombo, Giordano Bruno, Newton, Leonhard Euler, Michael Faraday, Darwin, James Maxwell, Mendeleev, Marie Curie, Einstein, John Van Neumann, James Watson, Francis Crick, Chen Ning Yang, Yo Tu. Generations of scientists have contributed to our understanding of the globe. New theories and technology are emerging and booming. We have never been as eager for innovation as we are today to explore our planet and what's beyond.
So we can see that innovation is not a new thing. So now I'll start the session with the presentation. So today's topic, wherein which we would like to discuss things about advantages of technological innovations and uses in entrepreneurship in the current 21st century. So I am Avnish Parikh from Oman, and I would like to bring your kind attention towards what is innovation in the first half of the presentation, and then how the technological advantages can be used, and simultaneously we will be doing certain hands-on exercises to learn more about innovation. Here I would like to have some promises from you during the session. So first I am going to those things. So before we start, we would like to see the objective of this session. The context is on the occasion of Engineers Day, as VC sir and PVC sir has rightly said that engineering is very important aspect and innovation is one part of it. And our, the great engineer Vishweswarayaji was doing a lot in the field, and he has so many, inventions to his credit, and so many other establishments he has done. So the context here is on the occasion of Engineers Day and in the view of integrated development of students towards entrepreneurship. We will discuss what is entrepreneurship and how you can be an entrepreneur. The vision today for today's talk is that our future looks forward to our present undergraduates and graduates as the true leaders of innovation and entrepreneurship. What would be the result of today's, let me tell you the outcome of today's session. You will find your own transformer. You know transformer, yes? You can see the GIF on the right hand side. You will find your own transformer. You will not remain a simple engineering graduate if you will follow my suggestions which I provide you today, and you will definitely find what is the transformer inside you. And if the things go the way we discussed today, definitely many of you will be entrepreneurs of tomorrow from your university. So the output would be graduates to innovators and upcoming entrepreneurs. So please be with me on this session. Be focused. It's not a simple like talk. Knowledge is everywhere present nowadays. You can go to Google, you can search anything, you can find like books and literatures and video and lot of things you can find. But the way we want to convey the message and we want to make you discover your own transformer. So in today's session, we will go with introduction, group agreements, food for thought, types of innovation, innovation to entrepreneurship, fostering innovation, and then reflections and end of session. So let's look into the things what we want first from you. So here I want all the participants, the first thing to say yes to me. Yes to me, not in the sense that everything that is 100% on point for you, but open yourself to it and build it on. So I want to ask you, yes, for opening up yourself and build upon the concept. You will see your transformation in days to come. Be present. Stay away from distractions. Don't use your phone or computer during the workshop. It's a small workshop. Don't go outside. Be present here. Be present with your concentration, full concentration in the workshop. Don't try to appear clever. This is a humble request. Avoid asking the smart questions if it doesn't contribute to anything. That distracts all the participants and that does not lead to anything. So I request you, don't try to appear clever. Be punctual. Punctual in the sense, this is a polite reminder to all the participants that time is tight and it's possible that we end a discussion because we need to move on to something. So please be with me during the entire presentation. Don't go much ahead and don't lag behind. I hope to all the offline participants, the material is already distributed to you or will be distributed soon. And to online participants, we will be sharing it in so I request Professor Shobna to share the document that I have shared in the morning with the online participants as well.
Definitely,
Okay,
sir.
ma'am.
So all the faculties in charges, Dean Dr. Sunil Thakurji, Dr. Sodhi, Dr. Praveen Sehgal, kindly distribute all this. I think you have already distributed the sheet material, a one page. It's already available, sir, with the students.
Yes, ma'am, already.
Great, ma'am. Great, ma'am. Thank you. Kindly share it with online participants as well.
Yeah. Online also we have already shared in the groups, and physically present students, we have given the hard copy. They are sitting in the auditorium
Great,
with the
ma'am.
Dean, SCT and the other faculty in charges and HODs of engineering. They are sitting in
Great,
the auditorium.
ma'am.
They have the
Great,
hard
ma'am.
copy with us, and they have already made the group as well.
Oh, great. Thank you. Thank you, ma'am. Thank you.
For your kind information, sir, 4 groups have been made, and accordingly, you can,
Yeah,
carry
we
on
will
as
distribute
per your
accordingly.
assignment. Yeah. Thank you.
Perfect, ma'am. Thank you, ma'am. Thank you. Thank you for all your help and support, ma'am. So, few other things which we want from you, from the participants, from the students. We have a parking lot. So during the entire session, should you get a very strong urge to ask a question, please park it in a parking lot. We will take it up at the end of the session. Kindly do that. We don't want any distractions in between. So it's really useful when you put a question. Otherwise, what happens sometimes, like question appears to our mind and we don't park it. So that's why it is already, it's really a useful tool when you want to keep your group focused on a topic. It allows to avoid distracting or interrupting my flow with something that is off topic at the moment. That could be really, like, I appreciate if you will ask me, but I request you to ask me at the end. So with these things, I think I am appearing too tough to you, yes? I'm putting you too much into the discipline, huh? Really? So I broke your heart? Are you sure? I broke your heart? Okay. Who did this? Dr. Parekh, huh? The resource person of the today's session. I was very tough to you? Okay. So you are broken heart. So I'll show you a small short film so you won't be like feel broken heart. Are you ready, guys? So let's see. A small film. Let's try to see if I can heal your heart again.
So what we do is we replace the stones for hollow spheres, which we fill with food and bacteria, and add that to the concrete mixture. Here we see an example of a piece of cracked concrete. You can see the crack and even a big hole. Here you can see that the bacteria have closed the crack and even the big hole completely filled with calcium carbonate.
So are you still feeling broken heart? Really? So it was a crack in a red wall. Yes? You are not feeling broken heart. And we filled the crack with the bacteria producing calcium carbonate and filling the crack. So next time you feel sad, broken heart, watch this video again and again. It's available on internet, and even if you want, I can share it with your professors. So they can share it with you. So don't feel any more broken heart anytime now onwards. Okay? Do you promise with me? Really? No? You think it was a joke? A poor joke? Really? Are you kidding? Okay. Let me show a clip from your area. You are from Haryana, right? Hisar. So I'll be showing you a clip from Sonipat. So try to see a clip from Sonipat as well.
How long will a manual labor take to lay 12,000 bricks? A few days, perhaps? But now we have a fully automated brick making machine which can make and lay 12,000 bricks in an hour. Satish Kumar from Haryana's Sonipat turned his family's failing brick business into an opportunity. He is the first in the world to make a fully automated brick making machine, revolutionizing the traditional brick making industry that is heavily dependent on labor. After dropping out of school in class 10, he spent about 4 years designing a machine that can mix, mold, and lay bricks automatically. And all of it when his long-running family-owned brick kiln shut down due to huge business losses. The incident shook Satish, but also made him evaluate the reasons for the failure. He noticed that the cost of manual labor was too high. When he looked for options, no company existed that could automate the process of brick making. And that's how Satish took to designing SNPC machines that holds a generator, a mixer, and a mold to produce bricks. Once raw materials are added into the truck, the bricks are ready to be laid. The mold gently drops the bricks and continues to do this with every inch the vehicle moves. This machine has brought down the cost of a brick from 60 paisa to 20 paisa. What started with a small machine that could lay 9,000 bricks in an hour can now lay about 12,000 bricks per hour. The SNPC machines already have consumers across Asia. In fact, they received the National Startup Award from the Government of India in 2020. What do you have to say about Satish's automated brick making machine? Do let us know in the comments below.
So did you watch the second video as well?
Please.
Okay. So what did you see in both the videos? What's your observation? What's your observation?
Yes, I think as a team member, Dr. Sunil, if any of the team member from particular group, one by one, can, accordingly, interact on behalf of other members, as per your assumption, as per the candidate assumption. What is innovation? You have seen two videos, are very beautiful videos. One is from for Broken Heart, and another one is Better India. So how you justify here that it's innovation here? What is innovation here? What is your thought? What is your assumption? Just give the clarity, give the picture on that.
Okay, student may be feeling little shy.
Yeah,
So I'll give some.
Yeah, please give, sir. Please give.
So I think that they can, like, they see certain things in them, those videos. What comes to your mind after watching these clips? Something new? Cool, right? Cool is a very, very common word among you, right? Cool. Anything you like very much or something new, you say cool. There is some culture, yes? Like the one you have seen, like bricklaying video, you see there is something, labor is not available or labor is very costly. So there is a particular trend. We have seen this thing. People go to their like fields or farms and they are not available to conventional industries. So that's how Satish came up with the idea of a bricklaying machine, S&P machine. There is economic growth. There are inventors. People have created value. There is research. Some kind of art is involved, products and services. Excuse me, please turn off your mic.
Good afternoon, sir. I'm Cyril. Sir, by seeing this video, I learned something. I get something new from my mind. Sir, uh, the bricks were made, the pixels are made in a past. It's with the man-made, but after seeing this, the technology was improved, and the machines are came. It will easy to the humans to uh, made the pixels, and the
Okay,
technology
great.
was awesome. And I want to develop this type of technology in future, sir. Thank
Great,
you.
great. Thank you. Great. So we see many ideas, we see big companies, we see money involved, we see the technology is there. So many things, so many words are popping up, so many terms are popping up in our mind after watching these videos. So what are these activities? If I look at these activities, these are common words coming to us, and we know since our childhood we are talking about creativity, discovery, invention, innovation. So, do you can you distinguish them all? Can you tell us like what is the exact difference, or what is creativity and how it is different from innovation or invention or discovery? So, while moving towards our path of learning innovation, what is innovation? We want to first know what is the creativity, discovery, or invention, or even innovation. So, let's take a brainstorming session. Your interactive session one. So in this session, you have a table with you. This is first interactive session, and in that we have given you creativity, discovery, invention, and innovation. These four things are given to you, and in key attributes you have knowledge, form, method of activity, features, and characteristics. So what you need to do below that, you will see certain terms given, and you have to choose one term each in one of these rows and columns for creativity, discovery, invention, and innovation. So carefully select the right term and try to put it in, and I give you 3 minutes time to do this thing. You have just 1, 2, 3, 4, 5. So 5 terms multiplied by 4. So in total, you have to put 20 odd terms in this table. Okay. In characteristics, you can even use 2 terms or more, but in rest of them, you have to use 1 term each. So your time starts now. And following this, I'll show you the answers, and then you can see, do you really understand creativity, discovery, invention, and innovation to what extent? So I give you 3 minutes time now. Please do the exercise. Come on, you can do it. Yes, good going, good efforts. Keep doing. Very good. Keep doing. Please turn off some mic is on. Yes, one more minute
Sir,
is still left with you. Keep doing.
sir, actually, innovation is the practical implementation of ideas that result in the introduction of new goods or services or improvement in offering goods or
Yeah. These
services.
Google, I know these Google definitions are available. I want to see your understanding, and I want you to, when you start speaking, please turn off your own like mic or something. Okay. Like some of the devices catching it because the mic is on. That's why there is an echo. So to avoid the echo, when somebody is speaking, rest of the mic should be off. That would be the first innovation we will be learning today. Perfect. Last 20 seconds and I'll show you the answers. Please turn off your mic. Everybody done? So let's see the answers. So creativity, knowledge status, when you see it's an idea, whereas discovery is a science. Invention is application of science, applied science, and innovation is application in business. When you talk about the form, please switch off the mic.
Sir, can we see again that slide?
I'll show again, ma'am. Somebody's mic is on. I want to request them to switch off the mic.
Okay. The mic should be off.
Thank you. Thank you all. Here is the slide, which is talking about creativity, discovery, invention, and innovation. The right answers are idea, sciences, applied sciences, and application in business. Form, a unique approach. Creativity is a unique approach. It could be unique to you or to your group, but it's unique. Discovery is actually a concept. Discovery is actually a concept. Then invention is a prototype and innovation is a product. When you talk about methods of activity, creativity is brainstorming. Discovery is actually research. Invention is development, while innovation is production. When you talk about the features of each one of them, creativity has low reproducibility. Low reproducibility in the sense you got the idea today, you may not get the same idea again, or you forget the key elements of the idea which you were pondering on a particular day. In other sense, low reproducibility, if you can do it, it may not be done by somebody else in your cohort, in your group, or somebody sitting at like 7 continents away. Whereas discovery has novelty in itself, invention has the feasibility, which is main feature, and innovation has utility, which is the most important feature. When you talk about characteristics, creativity is highly intangible, whereas it is very whereas it has very high malleability. When you talk about discovery, it's intangible with high malleability. When you say invention, it's moderately intangible, but yes, it's malleable. But innovation, it's tangible and immutable. So when you say a creativity, a new idea, something pops up in your mind, that's not innovation. You start working on it, you do some concept development, you do some research, you say, okay, fine, I fed my plants with a particular, I fed my insect with a particular plant leaves, and this is the new thing that the insect is eating the plant or not eating the plant or growing muscles in it, and that's just discovery. That's not innovation. Even if you find out and you develop something which is unique in itself, many of the inventions we see, you see, means like in news, you see, okay, this boy from Bihar has developed a new bike, or this guy from this place has developed a new technique to harvest solar energy. No, these are all inventions. They are not innovations until and unless they reach to application in business. So that's the thing wherein which you should understand creativity, discovery, invention, and innovation. Unless your research or your work, your invention can be turned into actual utility for the layman who doesn't understand any of your invention or discovery, the principles behind that, the concepts behind that, if he can utilize that thing comfortably, then it is innovation. So let's see further. Let's try to develop the concept a little more. So innovation is implementing new ideas that create value. Who said this? It's not me. It's the Innovation Network from USA, which is telling this, implementing new ideas that create value. There should be value addition. A lot of work is going on wastewater treatment and waste recycling and this and that. There are so many fields, and we are witnessing so much of science these days, as we never witnessed that much in, like, yesteryears. Ultimately, the idea does not work because it is not creating the value. Somewhere or other place, the value is missing. Somebody was telling me some 3-4 days back that I want to use graphene to, like, purify the water. Gentlemen, you are using graphene, nano level structure, to purify the water. How much water it will purify? In how much time? The moment I started asking these questions, the guy was like, oh, I never thought of these things. That's what you are supposed to think. The practical application of something. When the value is added, when the person who is utilizing it does not require any prior knowledge of concept, science, research, engineering, or anything, then it is innovation. So what do you want in life? Now, a lot of talking on innovation and research is done. What do you want in life? You want a profession, you want a vocation, what you can be paid for. Yes. Now, what you have in your hand, what do you have in your hand? You have what you are good at, you have your passion, you have your mission, and you have some little knowledge of what the world needs. You can think of what you love to do. I want to play music whole day. Okay, I love it. I want to do some kind of creativity. I want to make small projects using, Arduino, or I want to do some kind of research. Please switch off your mic, I request. So what do you want in life? Innovation can give you that. Because innovation ultimately leads to the problem is what there was a time when when students never used to go for research around 10, 20, 15 years back. If you see the data, you will find that there were very few people in PhD programs. People used to do their undergraduate graduates or graduate studies, and then they will straight away go for their work because they were getting ample job available.
Sir, is it done?
No, no, not done, ma'am. There is a mic open. I don't know. Means like a lot of disturbance is coming.
Okay.
That's why I stopped in between.
Just we have just for your information, sir, and for all the participants' information also, that we have with us another speaker also, sir, Dr. Koel Gaur from USA, all the way from USA, and he is also Biomedical Engineering School of Science and Engineering, St. Louis University, USA. So after your
Welcome, Dr. Koel.
Hello, nice to meet you.
Yeah, he will be delivering on tissue engineering simultaneously. Right, means after your this session, like her time actually is 3:30 since we little bit started late. So Koel ma'am, we can do it in another 10 minutes. We can start your session another 7 to 10 minutes after the sir finishes.
Perfect. So, what do we want in life? We want so many different things, and innovation is something by which you can achieve that. So, let's look into type of innovations. So, we have like all different type of innovations: disruptive innovation, and then breakthrough innovations, incremental or sustaining innovation. Another example of disruptive innovation, but they go with like technology and market hand in hand. You can do innovation in existing technology and the market is already there. You need not to discover something new. Initially, we used to use like, flash drives or pen drives, whatever you call them, small storage space, 8 GB, 4 GB, 2 GB, 256 MB or something like that. And it's not a very old story. And then way back in 2012, when I bought a 500 GB hard disk, people were telling in my department, what do you want, gentlemen? You want to take the entire department in your hard disk or what? And nowadays, even your phone have 512 GB. So it's like incremental or sustaining innovation. You are improving regularly. Innovations are being done. More space utilization is there. We have seen floppy drives, and now we are witnessing phones with 1 TB storage space. The new iPhone 14, I think, have 1 TB of storage space. CRT monitors, LCD monitors, we have seen. There is a new technology involved. So existing technology and new technology within the existing market. And then the new market, you know how the Netflix has changed our movie watching experience or our series watching experience and a lot of. Then Uber or something else, you can take Paytm. These are the breakthrough innovations. So innovations can be anywhere. You need not to discover the wheel again. It could be anything. No need to go run behind finding something new. Innovation can be anywhere. So now, what is the source of innovation? How many sources are there for you to innovate? So let's see. Institute. Can institute be the source of innovation? Your teacher, your guide, your mentor, what do you think can be a source of innovation? Your parents, friends, your customers, your research activity, your literature review, entrepreneurs, existing entrepreneurs, unicorns. We study somebody, oh, this guy has done this thing and now he's a He has established a unicorn. So can he be the source of innovation? Anyone else? Anything? So what's the source? Who? For whom? What? Where? How? What is the source of innovation? So let's look into the source of innovation. What you did not see, like when I was asking you, what comes to your mind when you have watched the first two clips, what I have shown you? You did not catch the word. Now let's see if we can really find the source of innovation. What's that? Finding a gap. If you can find a gap, and you have to find the gap, where is the gap? Gap is the market, technology, uses, raw material, or something else. Where is the gap? If you can see the gap, you can fill the gap. And that's what is the basic thing for today. Use of technological advantages to explore this gap. First, you have to identify the gap. Nobody is going to tell you the gap. Neither your institute, nor your mentor, nor your customer or family or anyone. You have to find the gap. But once the gap is identified, you can use the technological advantages to explore this gap, how deep it is, how wide it is, what should be done on this, and further use the technological tools to fill the gap. So what technological tools are available to us now? Let's see. So some technological tools, I'll not go into details of these tools, but some of the technological tools that are available like machine learning, artificial intelligence, deep learning, Soapbox, Stats, IdeaWake, Blockchain, Babel, QMart, so many of them, biotechnology. You have just witnessed one of the video in the beginning is through biotechnology. The calcium producing, like carbonate producing bacteria and filling the gap. Renewables, fermentation technology. Just one word, fermentation technology, and what do you see? Milk is just one commodity. And how many products are there? All are coming from fermentation technology. That's the beauty of the technology. That's the beauty of the tool. Idea scale, iLambda, Crowdicity, computer vision, crowdsourcing, programming, edge computing, so many of them, 5G network. So many of these tools are available, accessible to you. And that's why people say, I started that innovation is not a new thing. But why it is a buzzword now? Because access of these tools. People used to find a gap, but they were not having tools in earlier days. So it used to be like, 40 years, 50 years to reach to one new product. An agriculture scientist used to take like around 10 to 12 years to develop a variety. And now people are using modern molecular tools and developing the varieties rapidly, even testing them and reaching to the conclusion not very fast because of these tools. So you have to develop some of the tools, how to use them. You have to develop the skill sets to use those tools, and depending on the kind of gap you find. So let's take a brainstorming session, your interactive session 2 again. So innovate the pizza. Everybody eats a pizza, right? So you have to innovate your pizza business using any form of innovation. This is an existing thing. You have to come up with 3 things. So you have pen and paper. What are your deliverables? What's the idea and form of innovation that you are going to use? What value is added to the customer? And how to generate revenue. These are the 3 things you have to answer, and you have 2 minutes to do that, and your time starts now. What you can explore, you can think something on service, you can think something on value, you can think something on market, a business model, process, or product. Just 2 minutes. Now, Please start doing it. Take the pen and paper and please start doing it. Make a small group of 3-4 people and do it. Thank you. Feeling hungry, guys?
Yes, any response? Dr. Vinesh is asking. Any response, just think over it and accordingly tell, because, we have
Write
to
it.
fast.
Yes, write it and you can send that to me. I'll show you my email ID at the end, or through your professor, you can send that to me. What's the idea and form of innovation? What value is added to the customer? How it generates revenue? Still
Okay.
1 more minute is with you.
That's nice, sir. I think all the candidates, they have the screen is available with them. Now they can send their idea to the respective faculties and they can forward it to me in order to forward you. Right, sir?
Okay, ma'am. No problem.
So everybody can later on send the ideas and give it to us so that we can think that how creative thinking you have.
Okay, to give you some of the ideas, you may not be thinking about pizza much. You may be like thinking of its taste now. So I give you some of the ideas wherein which you can work. See, some of the ideas are there. How to hold a pizza slice, or how to cut it, or how you can make different shapes of pizza. See, pizza cone, or these type of pizza cups, or something like that. Or with the service availability, you can think of something on that. You can have like different pizza in one pizza. Okay. You can even use millets, if you can think using millets. So you have so many different ideas wherein which you can work with. You have to think creatively. Okay. Great. So we go a little ahead from pizza. Otherwise mouths will water a lot. So let's look into what is innovation and what is entrepreneurship and how they are linked. So when man started learning that the wooden logs roll in the beginning of the civilization, they developed a wheel. We all know this. And from development of the wheel, that was the invention, we had certain gaps. The gap I was talking with you. What was the gap? Control of that wheel. Carriage by the wheel. How I can sit on the wheel and I can travel the distance the way it is going fast. How I can like put the energy to this wheel. So there were so many gaps. Comfort, shock absorbing power. So many gaps were there, and gradually after innovating, people raised and made a car. And when the car was developed, later on entrepreneurship came up. So this is the connection of invention, innovation, and entrepreneurship through finding the gap. So you should, when you are working on some research project or your sessional projects, you should look for finding those gaps. Now, how your innovations can be fostered. For any organization to thrive in any market, empathy is the most important leadership skill according to the research. Have empathy within your group. Most often we have seen that groups don't work together for a very long time because somewhere empathy is lost. Empathy is the key characteristic. Ways to create an environment that fosters innovation. Yes, that is very important for organizations. And not every leader has the natural talent for encouraging innovation like Elon Musk or Steve Jobs. But yes, there are certain things we can think of when we want to foster innovation. So this is my humble request to all the universities and institutes and all the groups and their leaders, that they should look into ways and means of fostering innovation. So let's look quickly onto certain things for fostering innovation. So here are some simple steps those leaders can take to get there. Provide guidance, that's the first thing. Set the example, be the first one to do something. Encourage ownership. If you will do it, you may be the CEO of this company tomorrow. So the people should dream, and those who dream, they can do the most. Find team leaders should find the hidden gems. Team leaders should find and celebrate the diversity. Everybody is not same. He's not thinking like me. His answers are different from me. No, you should celebrate the diversity. If you are open to it, then you can do it. Embrace failure. If your group fails, you should not say that this is not done, this is not good. No, embrace failure. Act on great ideas. Examine leadership styles. People have different leadership styles. Leadership is not a unique thing. It's not like uniform thing. Every leadership is a unique way. So you have to examine different leadership styles. Pay attention to hierarchy. That's very, very important to avoid chaos in the group. Otherwise, your things will go into blaming each other and you will never reach to your goal. Set the table for great ideas. Always be ready to listen it.
Okay, wonderful
Now,
talk, Dr. Avinash. The university is indebtful for you for a wonderful discussion you have taken with our students and faculty. So now we have another speaker, Dr. Koel. So can Dr.
sir,
Somnath,
just 2 minutes to finish.
we already have lost our time,
Sir, last
Dr. Avinash, because Dr. Koel also has to speak, and the time is up to 4 p.m. only. We have left just 10 minutes.
I understand, sir. We have started 20 minutes late. I'll take just 2 minutes time to finish it.
Sir, if you allow us, actually our university students and faculties will be available till 4:30 only, because it's in outer skirts in the university and the buses will be moved. So if we can continue, if you allow us, we can continue, we can make it one more session. It's our request to you. That's what, for the session.
It's done, ma'am. It's done, ma'am. It's done.
Okay.
No problem, ma'am. Thank you. So the last slide, take home message, please write to me anything exceptionally interesting in today's session or idea of your upcoming session. Here is my mail ID. You can jot down my mail ID and you can write these things to me. Thank you. Thank you so much for the time and
Thank you, sir. Thank you, sir, for a valuable
patience and
input and a
special
wonderful session and
special thank
learning
to
for
the
the
management.
engineers as well. Thank you. Now, I formally welcome Dr. Koel Garg all the way from USA, and we are very thankful to you, ma'am, that you are here at this particular time. In your country, the time is very early morning, it's approx 5 a.m. I think. So it's our pleasure that we are getting you on board from St. Louis University, USA. Dr. Koel Garg, she is a biomedical engineer from School of Science and Engineering. Over to you, ma'am, for your valuable learning for the students related to tissue engineering, advances in tissue engineering. Thank you.
Okay, so I hope you can hear me okay?
Yes, it's very much audible. Please.
Okay, and the slides are clear too, right? Okay, so I'll just continue. So thank you so much for inviting me. I will be talking about advances in tissue engineering. So I'll just begin with the basic definition. And this has to do with the fact that if you think about a lizard or a salamander, for example, when they lose their tail or when they lose their limbs, they can often grow it back. As humans, we don't have that capacity. So tissue engineering is a field that hopes to provide that capability to humans. So it's an interdisciplinary field. And we have a mix of engineers and biologists that are working together towards the development of substitutes for tissues and organs. And the whole idea is to restore, maintain, or improve tissue function. So this field actually gained a lot of prominence in 1993. And this is where this definition was coined. Back in 1993, and here are the two pioneers who really led this field forward. So that's Dr. Robert Langer and Dr. Joseph Vacanty. So you may have heard of Dr. Langer. He also had a role to play in the COVID vaccine recently. Okay, so what does tissue engineering entail? So if you think about all the cells in our bodies, they all attach to something in order to grow. So what is that something? That's just known as a matrix. It's a matrix of proteins. It's very fibrous in nature, as you can see here in this picture. So the cells kind of reside in between this matrix, and they attach to this matrix in order to grow. And in addition to that, these cells, they also need some chemical signals. Right, so those chemical signals are most likely coming from other cells in the vicinity. So those are the two things that these cells are going to need in order to survive, in order to grow, in order to combine themselves into tissues. And this is often referred to as the tissue engineering triad. So there are three things you need to regrow an organ or to develop a new tissue. So you need some type of a material. It needs to be a biomaterial that can allow for cellular attachment and growth. You obviously need cells, and I'll talk a little bit more about them. And then you need a whole bunch of chemical signals. Now, these are commonly referred to as small molecules. They are soluble. They can be growth factors. They can be cytokines. So that type of stimulus is needed. And when you put all three of these things together, if you have the right conditions, you can grow an organ, you can grow a tissue, or at least conceptually, that's the hope. Okay, so over the years, there has been a lot of progress in tissue engineering. We are getting better at engineering cells, meaning that we can take any cell, we can manipulate it, to serve a particular function. We are also getting better at engineering materials. So we can design new types of chemistries. We can design new types of topographies. 3D printing has completely changed the landscape. So now you can create any architecture that you want. And then we also have another tool in our arsenal, which is a decellularized organ, as I'll talk about in just a minute. So here's just a brief timeline of all the advances in tissue engineering that have happened over the years. You may have heard Dr. Anthony Atala. He engineered bladders and he implanted them in patients. And some of those patients are still alive today with a fully functional bladder. We also have had tracheas replaced in humans. So those are two of the most successful examples of tissue engineering that have really propelled this field forward. And this all started in 1997, so just a little bit of history. So this mouse that you see on the screen there, this is known as a Vacanty Mouse. So what the researchers did was they were trying to create the outer lobe of the ear, and they were using this mouse as an incubator to allow for it to mature. They implanted it in these mice, And this mouse went on to appear on the covers of several magazines. And the public reaction at that time was highly mixed. Some were excited, some were outraged, some were just scared, right? So how did they do this? Well, at that time, 3D printing wasn't around. So they just took some pictures, they created the shape of an ear using some materials, some of those materials that are acceptable for tissue engineering. So those are usually polymers. So polyglycolic acid, polylactic acid being a most common one. Then they took they took cartilage cells from a cow, and they seeded it on this template of the ear that they had made. They allowed it to mature at 37 degrees C for a little bit, and then they implanted it in this animal. And this was the very first example of tissue engineering, and they were able to show that we can now grow cartilage on the backs of mouse, and it is functional, and it shows the right kind of morphology. But what about humans? Today, let's say I lose an ear to an accident or some other traumatic event. Can I get one? The answer is no. So this experiment happened in 1997. We still don't have ears or outer lobes of the ears available for humans to be implanted. And there are a variety of reasons for that. So first of all, this study was done in a mouse. Mice, they heal very quickly. They have different types of systems. So it's not always translatable to humans, right? So that was one of the major reasons. But in 2018, the study came out from China and Japan, where they repeated this exact same experiment from 1997 on children. And they were able to take advantage of the new tools and techniques like CT scanning, 3D reconstruction, 3D printing, and they were able to prepare these scaffolds. They this time didn't use cow cells, they used the cells from the children themselves. And they were able to create a reconstructed ear that could then be implanted. So this is how long it took for us to reach this stage. And also, they made another innovation in here. They made use of a new material. It's known as polycaprolactone. So they also changed the type of material that they were using for this experiment, which had better mechanical strength and some other attractive properties. Okay, so how long does it take once you are in the lab, once you develop something, once you develop a tissue, how long does it take for other humans in the population to receive it? Well, so it's a very iterative process. It takes a really long time, starting with discovery to prototyping to animal testing to human testing to safety testing. And then it goes to post-market monitoring. So it can take greater than 10 years for you to get a tissue engineered product developed in the lab to the market where it can be available for general use. But there are some successful examples. So all is not lost. We do have some other examples that are out there. So one of those is known as a Dermagraph. So this is marketed for diabetic foot ulcers. So in diabetic foot ulcers, these are kind of open wounds that don't really heal. The healing is arrested in those wounds. So you can use tissue engineering to enhance wound healing. So once again, this has that same mix of polymers using which that ear was made on the back of the mouse. So you have polyglycolic acid, polylactic acid, and this is what that biomaterial looks like. This is what this material looks like when it comes out of the packaging. And in addition to that, it also has human fibroblast-derived cells. So what are those cells? So these are essentially your skin cells, and they are taken from hospitals where skin tissue is discarded after some type of operation. So essentially, it's medical waste that this company is using. So they're isolating cells, they're putting it on this material, and they are then freezing it and then they are selling it. So whenever you need a material like this, it can be thawed and it can be delivered to the patient. This product has been very successful. It also has new versions coming out. But essentially what happens is once you seed the cells on this material, they occupy this interstitial space, these pores in the material, and then they completely occupy it after a while, and then this product is ready at that stage to be implanted into humans. Decellularization is another important advancement in the field of tissue engineering. So essentially you take native organs like your kidney, your liver, or your lung, and you treat it, you wash it with some detergents, with some chemicals, to essentially get rid of all of the cells that are in there. Okay, so if you're getting rid of the cells, what's left? Well, what's left is this white matrix of proteins that I talked about earlier. And now this is a perfect biological material for you to design your own tissues or your own organs. So this decellularized tissues, they are available as intact tissues, as you can see here. They're also available in form of gels. They are available in form of a powder. So they can be then used to treat chronic conditions or open wounds in patients. So one such example is MACI, or matrix-induced ACI. So essentially, this is marketed for osteoarthritis. In this particular case, your cartilage that's in your joints, it experiences wear and tear, and you could have a lot of pain in your joints. That's osteoarthritis. So in 1997, FDA approved a product known as ACI, or autologous chondrocyte implantation. So essentially, in this case, if you have somebody with terrible knee pain who they cannot walk, they'll go into the clinic, they'll have a little bit of cells taken from their knee joint, they'll culture them up, they'll grow them up, and these cells will make copies of themselves. And then you will take those cultured cells and you'll implant it exactly where that damage is in their knee joint. And to keep the cells in place so they don't leak out because they are being delivered as a solution, you also take a little bit of a bone graft and you put it on top of that cell patch. But as you can imagine, you are bringing the patient in who's already in pain, and now you have taken their cells. You also are taking a little bit of their bone. This is not going to be good, right? So there was a little bit of innovation in this field, and they came up with a decellularized material, a material that I just talked about. And they decided to culture these cells on that material and then implant it. So the second surgery, where a piece of bone was typically taken out to attach over that solution of cells, that was no longer necessary. So it led to faster recovery times, less painful procedures for the patient, and it showed very good clinical results. So this was approved in 2016. Once again, an example of taking an existing technique and improving it and making it better for good patient outcomes. Okay, and this is the last product that I'm going to talk about in the interest of time. So this is an infused bone graft. So this is used for spinal fusion. So this is a procedure that's done if you have some type of a problem in your spine, meaning that you have lost mechanical strength of your spine because of degeneration or degradation. This typically happens as you age. So essentially what the surgeons typically do is, here are the two bones of your vertebra. They take those two bones, they clear out any damage, and they fuse them together. They put some screws in, they stabilize the structure, and they take autologous bone, so meaning a bone from another part of your body, and they engraft it there, and then they restore its mechanical stability. So infused bone grafts was invented to essentially improve this process. This bone graft, once again, it uses kind of a decellularized material. So a material that's derived from, physiological systems. It could be derived from humans. It could be derived from animals. One of the most commonly used matrix material is collagen. They took that collagen from physiological systems. They created a sponge-like material out of it. And then they used one of those chemical signals that I was talking about. So cells need some of those chemical cues, chemical signals in order to survive and grow and maintain themselves, right? So bone morphogenetic protein 2 is one such chemical signal that bone cells need. So they took that collagen sponge-like material and they added this BMP2 onto it. And then when this was implanted, instead of your own bone from, let's say, another part of your body, then that led to really good outcomes, because now you have the sponge-like structure, as you can see from this picture here, and you put this BMP on it. And then once you implant that, the cells that come in inside that spongy scaffold can now deposit new bone. This sponge, because it's made of biological material, it degrades or dissolves, and any cells that get into it now start to deposit bone tissue, right? So this has been on the market since 2002. It has been implanted in millions of patients worldwide, and it has had very good outcomes in terms of reducing operating time, reducing blood loss, preventing the need for isolation of bone from the patient. So in closing, I just want to reiterate that since the early 1990s, tissue engineering has transitioned from a concept to a very significant field where we are creating value, where we are adding something meaningful, and we are improving the human condition. And as I showed you, there are a variety of tissue substitutes that have been engineered, that have been successfully used to treat patients all over the world. And this is only possible through collaborative scientific effort. So tissue engineering is a field that requires mechanical engineers, electrical engineers, biologists, chemists, right? So this is highly collaborative. And if everybody comes together, we have the potential to reduce healthcare costs and bring substantial benefits to patients' quality of life. So I'll stop here, and I'll be happy to take any questions if you have them.
Okay, Dr. Goel, Dr. Goel, ma'am, do you want to ask something, some question answer, or it's over?
No, it's over.
The presentation is over?
Yes.
Okay. So anybody would like to ask something, they can put it on the chat box, either one or two question, or either we can take it forward through the mail and send it to ma'am to ask some answers, right? So this is, I think,
Sure.
a wonderful thing, for the time saving also, right, ma'am? So it's
Yeah.
really a wonderful session related to advances in tissue engineering and how it relates to innovation also. Actually, tissue engineering, as ma'am said, a newly emerging biomedical technology, right, ma'am? That to
Yes.
assist the regeneration and repairing of damaging tissues. So I think the students and faculties all the participants already got the very good learning and inputs related to advances in tissue engineering, and it's really a learning session for all. Thanks a lot, ma'am, for this wonderful session. And
Thank you.
yeah, thanks from the Home Sterling Global University for this session to you, to Dr. Goel as well as to Dr. Amnish, both the participants. Hopefully all the candidates learned a lot during this session. Thank you all. We can wait for a 5 minutes. We can wait for a 5 minutes. All are requested to wait for a while only, for 2-3 minutes. So we all must rise from our seats for a national anthem, please.
जनगणमनाधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधितरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you all. Thank you and have a wonderful day. Best wishes to all.